Hi, I'm Maryam. I'm a PhD student at Northwestern, and I'm going to be talking about our paper, Subjective Probability Correction for Uncertainty Representations, with my co-authors Fumeng and Matt. So I'll start by taking us back to the US presidential election in 2016. So I was in Egypt, I was 6 hours ahead of the US, and so I had to go to bed without knowing the election results. So before I went to bed, I looked at the New York Times. I saw it said that Hillary had an 85% chance of winning, so I told my roommate, okay, so she's definitely going to win. The next morning when I wake up, as you all know, she did not in fact win. So in an ideal world, when I saw this 85%, I should have felt like it was 85% because I want to be interpreting probabilities accurately. What actually happened is that I was rounding this 85% to something closer to 100%, with a pattern that looks something like this, which is something that we see in the literature. So people tend to overestimate high probabilities and underestimate low probabilities. So how can we help people better interpret probability? One way is to use better visualizations, but there seems to be an upper bound on how much we can improve using better visualizations. So what if instead we show people different probabilities to compensate for their bias? So if I was going to round that 85% up to 100% in my head, maybe they should have showed me 75% instead. So there are other examples of correcting for people's biases like this. So there's a perceptual bias that people are pretty bad at estimating the areas of circles. So this second circle is double the area of the first one. So what people sometimes do is make that second circle bigger than double the area so people perceive it as double the area. We want to do something similar. So if we want to convey to people that a particular candidate has a 19% chance of winning, we might show them something like this, which is actually 41%, but that might feel more like 19%. So let's find out if we can actually do this. So to do this, we first showed people election forecasts in either graph form or text form and had them answer questions about it. We then used that to get a model of how biased people actually are. The next thing we do is figure out what we can show people that will feel like 19%. So in this case, that's 41%. And so we show new people that corrected forecast to see if they will get closer to that straight line, meaning they're interpreting probability more accurately. So for this first part, we had a US demographically representative sample. So they saw a particular election scenario in which candidate A had a particular percentage chance of winning, where they were choosing between winning 100 points if a coin flip resulted in heads or 50 points if candidate A wins. And again, half the people saw this in text form rather than graph form. So we want to use those betting decisions to figure out people's subjective probabilities. So how do we expect people to answer these questions? So for option 1, the expected value is always going to be 50. For option 2, we expect people to multiply the reward by their subjective probability of that candidate winning, in this case 30%, to get the expected value of that option and to pick the higher one. So in this case, they would choose option 1. We expect them to do the same thing for each one. So in this case, 350 times 30% would be 105. So they would choose option 2. So when they answer these questions, maybe they answer in a pattern like this. We don't actually know their subjective probability, but if they answered these questions the way someone would, if their subjective probability was 30%, then we assume their subjective probability is 30%. And then we use those probabilities to get the shape of the curve and see our paper for more details on how we did this. So when we did this, we did actually see this S-shaped curve in both the graph and the text condition, especially in the text condition. But how do we quantify how close these curves are to that straight line? So we have 3 metrics we're going to use, and the first one's alpha. So alpha basically measures whether people are generally over or underestimating probabilities. That's an alpha of 0.5, that's an alpha of 0, and that's an alpha of negative 0.5. And we want alpha to be 0. What we actually saw was something like this, where people were generally underestimating those probabilities. The second measure is beta, which basically measures how curvy that line is, how steep that slope is. So this is a beta of 1, which is what we're going for. This is a beta of 2, and this is a beta of 4. So we want that beta to be 1. And what we instead saw was something higher than 1 because we had that S-curve. So the final metric is the integrated absolute error, which measures basically the area between the curve and that line. So we want that to be 0, and again, we get something higher than 0. So the next step is figuring out the distribution we want to show people. We start with the forecast that we're trying to communicate, and we look at the complementary CDF of the distribution, which is the probability of getting over any given percentage. Then we use the subjective probability function to figure out what probabilities we should show people. And then we turn those probabilities into a distribution that we can show people. And this is one of 2 pre-registered corrections in the paper. So to figure out if our correction worked, we used our 2 pre-registered corrections. We recruited 603 new people, And we again used a US demographically representative sample. And we had people do the same thing, but they now saw corrected versions of those distributions for both the graph and the text conditions. So as a reminder, this is what we saw when people were looking at the uncorrected versions of the distributions, and then this is what we saw when they were looking at the corrected versions. So visually we can see that it's a lot closer to that straight line. So alpha, again, we want it to be 0. Originally we were somewhere around here, and after correcting we were closer to 0. Beta, again, we want to be 1. In phase 1 we were somewhere around here, and in phase 2 we got closer to 1, especially in the text condition. We want the IAE to be 0. We were originally here, and after correcting we got better. And again, we had one other correction. The results looked pretty similar to this one. So sweet, it worked, but why didn't it work perfectly? Why are we not getting a perfectly straight line? So one possibility is that not everyone used that optimal strategy we were assuming they were using, and we had qualitative responses where people told us what strategies they were using. So about 42% used both probability and reward, which is what we expected them to do, where they were multiplying reward by the probability. But a bunch of people did other things. So about 47% just looked at probability and didn't care about reward. Some people only picked based on what had the highest reward. And then some people were just randomly choosing. So it makes sense that our correction wouldn't necessarily work on the people who weren't using the strategy we assumed they were using. So would this work in other contexts? We think it would. So you'll first need to elicit parameters for the correction. But if you're doing US election forecasting, we think that our parameters would work since we used a US demographically representative sample. So then the other question is whether this is ethically okay. And one thing to think about here is whether the goal of an election forecast is to communicate precise probabilities or whether it's for people who are looking at the forecast to have some intuitive sense of how likely that candidate is to win. And what we're doing here is pretty similar to adjusting the size of circles to account for people's biases. Whether this feels ethically okay might depend on the decision context. So for example, weather forecasts tend to overpredict the chance of rain because people are happier if they're told it's going to rain and it doesn't than the reverse of that. There also might be ways to apply these kinds of corrections more transparently that might feel more ethical, but I think the answer to this question is not that simple and is definitely worth discussing. So thank you so much to my co-authors, and feel free to take a look at this OSF link for more information about our paper. Thank you.